Every day, we breathe 25,000 liters of air. A distribution center is particularly exposed to harmful particles from exhaust fumes and dust. At Schenker Investors, there was a health concern. Camfil was commissioned to install its patented clean air solutions. This led to 30% lower heating costs, despite a terminal with many access gates.
Welcome to our next Metflix metsoc.mcgill chapter. My name is Panza. I'm here with Wei and Mahmoud. Currently we are at Camfil Power Systems, and today we are going to have an interview with Joshua Kohn and Sophie Belanger. Before starting, I would like to thank you both for taking your time and having us here. So we're going to start with a couple of general questions first. Tell us about Camfil. What does it involve and what is your role here at Camfil?
Hi. Well, first, thank you for interviewing us. So what is Camfil? Camfil is an air filtration company. And specifically here you are with Camfil Power Systems. So we focus really on air inlet filter for gas turbine and other turbo machinery. I work as a product manager.
And my name is Joshua Kohn. I work as the R&D Manager.
And maybe for a little bit of fun, maybe you can let us know what is beyond engineering in Camfil. For example, the team activities, fun activities.
I mean, maybe we have a look around a little bit later, but we have a very, very nice kitchen with a lot of games in there. So you've got pool, you've got foosball, you've got ping pong, a really nice gym in the back. I think people generally here are very active. Food is a big part of things, so people like to cook and make different sort of food, very diverse culturally. So everybody come and try to make us food from their own region or where they come from. And yeah, I mean, we're a big fan of squash, so after hours we play a lot of squash and other sports.
Okay, so could you please tell us about your projects? Like how many branches do you have in the world, and what kind of project do you want to do in your company?
So Camfil is a Swedish company. They're founded in Sweden. Their head office and their tech center are still right outside Stockholm. And we have offices all around the world. So we have offices in Canada, in the US, all across Europe, in Malaysia, Brazil, China. So all different R&D factories, R&D facilities and factories.
Great.
So, on top of that, maybe you can let us know to what extent materials engineering is being used in your company.
That's a tough question because I think materials engineering is quite broad. So here I think the most applied or the most direct use of material engineering is when it comes to R&D and product development. Here we have a lot of characterization of media when we look at new product development. I mean, there's a little bit probably of material engineering when it comes to our engineering group that develops the air inlet filter, but that would be a little bit more mechanical engineering as well. So it depends where you make your specialization in material engineering. We've got some work on the foremarket with metals, and on the aftermarket, it's going to be all other sort of filter media, plastic, glues, and other types of materials.
Yeah, if you look at the air filters that we make, they're all made of, there's a lot of glass fiber filters, there's a lot of cellulose and different synthetic media used, and we do a lot of work in specifying what we want the filter to be made from and what properties we would get rid of the ourselves to do.
It seems like you have different lines of products going on. And maybe you can let us know about how materials engineering students or interns have been involved in different departments and what they are looking at.
Right now we've got, I think, 2 material engineering interns. One of them works with supporting the product team, one of them works with supporting the R&D team. So the type of research we've asked them to look at was, for example, looking at new resin to coat some of the media and see if they can do a research on how those resin age with time and how do they react in different environmental conditions. Our filters will be supply an area as diverse as an offshore platform or like a desert in Saudi and or North Siberia where it gets really cold. So material reacts in different ways in different environmental conditions, and it's really important for us to know upfront. That's one of the examples that comes to mind right now.
Another example is the filters we make have to be waterproof. So there's a lot of work being done on different hydrophobic or oleophobic properties of the filter mediums. So we have a couple different test methods that we do here that we have our interns working on that help us then specify the right types of materials to use in finished products.
And then please tell us about the types of tests that you run on your product to make sure that they can maintain the severe condition. So what are the type of tests that you run?
Yeah, so there's different types of tests on the filter. Typically, what the first things we look at is kind of the basic for an air filter. What's the efficiency of the filter? What is the pressure drop? What is the burst pressure of the product to make sure we don't get damage to whatever it's protecting, in our case, gas turbine. That's really kind of the standard. And then we start looking at qualifying environmental conditions. So we've talked about cold tests, we've talked about hydrophobic tests. There's probably quite a lot more on the media themselves that we do as tests as well.
Yeah, so we have two types of tests that we do. One is on just flat sheets of media, where we'll get an 8.5 by 11 sheet of all different media grades, and we have different tests on tensile testing, the filters, burst testing, strength of the filters, water column tests on the media itself. Once we have a media that we like the property of, then we'll fold that into a full-size filter we see right behind us. And we have the large wind tunnel just in the background where we test our full-scale filters. So here's our main recirculating wind tunnel that we use for full-scale filter testing. So we have our filter elements here. We have a metal coalescing filter and a glass fiber final filter that we're testing the performance of. So once we know the properties of the flat sheet media and we're happy with that, we then build it into a full-scale filter. And we put that into this wind tunnel to test how it would work in actual conditions. So we have our fan in the bottom right corner. There's our metal soundproof box right down over here. And that is recirculating air all around. We then have some HEPA-grade filters in this cabinet over here to make sure that the air that gets recirculated is very clean air. So then we have the air that then comes all the way across here onto the inlet side, and then it gets pushed in through the filter outlets. Once we know how much air we have, and we know that it's very clean air, here's where we could inject all our different contaminants. So we could mimic dust storms and sandstorms. We could mimic high humidity. We have our water spraying nozzles over here built into the ducts so that we could test the hydrophobic properties. So it's all about mimicking on-site conditions, spraying different salts, either NaCl or KCl, different contaminants, either spraying different types of dust or different types of oils, and then seeing how the filters react. A big part of what we do is using the particle counters that we see here. So we use these metal L probes, these isokinetic probes, to take a sample of the air before the filters, as well as to take a sample afterwards from this probe right over here. So we can count how many particles you have before the filter, how many particles you have after the filter, of no matter what you're throwing at it, whether it's dust, oil, water, salts. We'll count how much that filter catches. That's really a lot of what we do here.
Generally, we have really two types of air inlet filters for gas turbine. We'll classify them as either static filters or pulse filter. When we look at static filter, we really try to stage the filter. So we'll have very coarse, typically cheaper pre-filter that we put in front of the final filters. They will be there to stop coarser dust, so larger particulates, and the goal is really to prolong the life of your final filter. Why do we do that? Well, we don't want to have to stop our operation to change the final filter, right? If your final filter lasts longer, you can run your turbine longer. So, by example, if a turbine is used as a power plant, it's coupled to a generator, probably is not allowed to stop for a year or 2 years of operation. So you need to make sure that this final filters last as long as the turbine needs to run. So you protect it with either 1 or 2 stage of those static filters. And you go with increasing media area. So a coarse filter will have a little bit less media, it'll be cheaper. Then you increase with bag filter, what we call pocket filter. And you see already that you have multiple pockets out of a longer length, so you can increase more media. Typically quite very lofty media with high dust holding capacity. And they're also there to, with the multiple stage, it helps removing water across the stage. If you have water that would end up on the clean side, it would also be very often very dirty water, because all of the contaminants that are caught in the filter get dissolved in the water, and then you defeat the purpose of protecting whatever you're trying to protect. If you look here, that's typically our final filter, mini pleated or compact filter. Here you see that we've pleated the media pack very tightly, so we fit in a lot more media in this, so that increase your dust holding capacity, also reduce the pressure drop. So the pressure drop is really the work that your engine has to do to bring the air across, and it's a matter of cost. So if you think of a gas turbine, the lower the pressure drop, the less fuel it burns, or the more power output it has. So it's very important also from an environmental perspective to have good air filter, because it reduces your CO2 output into the atmosphere. And we'll do extremely long filter like this, much more massive, when we want to increase the life even further of the filter. So these are all static filters. Stage filter for environment where, by example, you have fine particulates, you have a lot of water. When we get in areas that are a lot more dusty with coarse dust, we'll look at self-cleaning unit. When we look at self-cleaning type of filter, what we use is compressed air and a rapid pulse of air to clean those filters from the dust that accumulates. So if you have your airflow from the outer in, and you'll have a dust cake on the top of your filter, and you're, by example, in a sandstorm condition where the dust keep up coming with really high concentration and really rapid rhythm, you don't want your filter to clog. You don't want the pressure drop to start shooting up and, by example, tripping your turbine and causing some unexpected downtime in a power plant. So we clean it with a shot of compressed air that will release the dust out back in the environment. And we keep pulsing those filters until they go down to a certain level of pressure drop. So for, by example, the Middle East region, these are the type of filters we will provide. When it comes to the different materials in the air filter, it really depends on the application in the environment. If we look, by example, on the filter media, on this one first here, we're looking at a cellulose and synthetic blend, but the majority of the fibers in the media is cellulose. It's typically a lower cost type of filter, older technology. And the big disadvantage with cellulose filter is that it reacts with humidity. So you see on newer technology and more, let's say, high-end type of filter, we've moved to synthetic type of fibers. These have the big advantage to be a lot more inert when it comes to reacting to humidity, so you don't see pressure drop spike. Other things that we do, and you can't really see it when you look at the filter like this, is how do we play with the fiber size and the arrangement of the filter. On these type of synthetic media, here what we've looked at is a media that's a little bit more depth loading. So we've arranged our filter media to have fine fibers that are very well spread out within the media, so that as your dust come in, it spreads through the media, and if your dust swell, it doesn't create a pressure drop increase. Other filter that will be a lot more focused on a dry area and dust area, you'll put, by example, the fine fiber just on the top surface of the media. You'll create your dust cake as a top layer. that will pulse clean well, but if you'd have all of your dust on top of the media and high humidity, you'd see that dust cake swelling and blocking the airflow. So a lot of the technology of the material arrangement that we see in air filters, you can't really see from just looking at the filters. You need to go a lot more in details to what you're looking at inside. Much more simple material selection will be what type of end caps do we put? Do we put galvanized? Do we put powder coated? Do we put stainless steel? The type of glue that we're using, do we have a glue that is soluble in water? Do we have a different type of glue that will resist water as well? Potting is very important for strength. We've seen on some low-end filters where the filter were actually falling from their end cap because the potting glue was not resistant enough. If you look internally as well, you'll have a screen inside where we also look at the type of metal that is used and the thickness of the metal, the openings as well, not to reduce the pulse. And yeah, how do you keep this together? So you see, for example, on this filter here, we use just a very small thread. In this case, is to keep limit the restriction to any dust release. On some filters, they'll be using a cage on the outside to add some strength to the filter as well. And in this case, they also block a little bit more the dust being released. But for some customer, for handling purposes, they prefer to protect the media a little bit more. So there's variety of engineering choice that you have to make when you design your filter, depending of where you're going to use it and in which application and what's your customer requirement.
Could you please tell us about your customers and also your company just sell only the filters or you provide all the system for customers?
So we sell not only the filters, but also the entire intake systems to our customers. We have two main types of customers. One are on the power generation side or on the oil and gas side. These are the two different customer types. We supply, Camfil Power Systems is supplying filters to the gas turbine industry. Anyone who is using a gas turbine either for to spin a generator, make power, or to spin a compressor for pumping any sort of fluid.
Here, that will be an air intake system, everything that is blue and yellow. So this would be like a full-size air inlet system on a site, but we'll look at a small model just to show you what is inside. So if you look inside of an air inlet system, you really start from this side here on the outdoor air. So your airflow is going in here from the left to the right, this way, and you start with weatherhood. So you want to remove the bulk of the water when it's raining outside. The first stage here is a droplet separator. So here the idea is we look with a little bit of turbulence in the air, and the droplet will have more inertia than the air, so it will keep going straight and it will hit the vane and drain. So we remove a big part of the bulk of the water with this first stage. This is important for pressure drop because otherwise pressure drop on your filter will rise, causing problems. The next step is your pre-filter. So we'll have one filter bank here that is made to hold pre-filters. So either small panels or bag filters typically, removing coarse dust and your first remaining smaller droplets here of water. Idea, then we keep some space between the two filters, one for maintenance to change the filters, but also to let the water that will have coalesced with your pre-filter stage drop out of the airflow and drain from the bottom. Then you have your final stage. You can do sometimes here two, depending on how much availability and life you want on your final filter. And you have your fine filter, typically EPA filter. So removing all the fine particles, all our hydrocarbons are the particles that can cause problems to your air filters. And that will move into a transition, and further down this way, you'll see you'll have ducting and inlet silencer going into the gas turbine, so you have fresh, clean air there.
When we're using these filters on gas turbine power generation applications, it's all about keeping these engines making as much power as they can, as reliable as they can, and burning the least amount of fuel to make that power as possible. So the goal of the air filters here is really to keep the air as clean as it can going into the engines, to make sure that these engines, when they're running on very corrosive environments, when they're running on next to the coast, when they're running in very dirty environments, when they're running on oil and gas applications in refineries, you want to make sure that all these contaminants don't go into the engine and then rust them out, needing costly repairs every couple of years. So to make the power grid as reliable as you can, we use these air filters.
Your friendly advice to fresh graduate students?
That's a tough one. Yeah, be curious. I think when I started working, I never really thought air filters could have anything interesting whatsoever. But the more you know about a subject, the more you kind of understand the complexity of it. And you know, it's been me 11 years. I keep learning something every single day. So be curious. Whatever subject you're going to go into, whatever field of industry you're going into. Thank you.
I like that advice. There's always problems worth solving. You want to be finding interesting problems to work on. Engineering is all about being curious about how things work and always wanting to do better. I found in industry, your job changes every couple of years. You're never doing the same task twice, which is interesting. And I've always found that programming is very underrated. There's always a lot on that side to be done.
Thank you. And finally, could you tell about your internship program, if you have any internship program for students?
Yeah, so we've had an internship program here for a couple of years, where we have several interns on different tasks. So we have two teams that are hiring interns. We have the product team and the R&D team. On the R&D team with me, we typically have 2 to 3 interns taking on different projects in the lab, looking at different aspects of filters, running different tests on both the full-scale filters in our wind tunnel, as well as looking into material properties.
And at the end, I would like to thank you both for having us here and for your time. And I hope this video helps you to find your goals in your career. Thank you.
Thank you.